So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over inequality linear graphs. Now an inequality can be plotted on a graph. The result is a region that lies on one side or the other of a boundary line. Now in a linear equation you only have a single x and or a single y in the equation. Now it is possible for you to solve quadratic inequalities, but again I'll include a link at the end of the video for you to extend that. But again, that's really covered in higher GCSE or further maths or at A level. Now with this particular topic, this is quite heavily marked, so there will be quite a lot of marks on offer, so therefore there are going to be a couple of steps for you to go on before you actually see your correct answer. Now the first step to plotting and representing inequality on a graph is to plot the equation replacing the inequality symbol, which is either less than, more than, less or equal to, or more equal to, with an equal sign. So that's our very first step. Now the next step you then need to do is calculate the coordinates by drawing a table of values and then plotting these coordinates on the set of axes. So again, this is covered in a previous video on plotting linear equations, which again I'll include a link on the screen as you can see here. Now the next is to join the coordinates with either a dashed line or a solid line depending on the inequality that's in the question. So for example, if you've got either a less than or a more than symbol, then what we need to do is connect those coordinates with a dashed line. And if it's either less or equal to or greater or equal to, then you join the points up with a solid line. And that's, again, quite an important step. And again, if unable to plot an equation, is going to be really difficult for you to move forward in this particular topic. So it's definitely worth including in any notes or revision notes that you are making. Now the next step is to shade or label the region the inequality represents. Now if you've got either a less or equal to, then the region represented is to the left if it's a vertical line, or below if it's a horizontal or diagonal line. So for example, if I had a let's say a vertical line that's dashed and I had less or equal to, then it will be the region on the left. If I had, let's say, a diagonal line or a horizontal line, again that should be horizontal, then it would represent the area that's below the diagonal line or underneath the horizontal line. And the opposite of that, so if you've got either a more than or more equal to, then the region represented is to the right if it's a vertical line, or above if it's a horizontal or diagonal line. So again, if I just repeat the process, so if I had a vertical line, then the region that it's wanting is to the right, and if it's a diagonal line, let's say do it the opposite way this time, or a horizontal line, then it's going to be above the line in both cases. Now to check you have the right region, you can pick a coordinate that is not on the boundary line and test it in the inequality. If it satisfies the inequality, then that is the side that's required. If it doesn't, the other side is required. Now again, I can't stress this enough, it is vital that you know how to plot a straight line equation on a graph, and again I'll include several links within this video before we actually move on to some examples. But again, I would definitely include this in your notes in terms of methods on working through these particular types of questions. So now let's have a look at some basic examples. So in this question we're asked to shade the regions represented by the inequalities. So in our first one, let me just label these 1, 2 and 3. So in the first one we're asked to sort of represent the inequality of y is less or equal to 3. Now as mentioned, what we're going to try and plot is we're going to plot y equals 3. So replace the inequality symbol with an equal sign. Now if you remember from the previous video on plotting linear equations, that y equals 3 is a horizontal line. So again, if I just highlight just 2 points on that line, the line is going to be y equals 3 is going to be represented by connecting those two marked coordinates. Now because it's less or equal to, what I need to do is I need to plot those points with a solid line. Now obviously it's going to be not very set in a good example because I should be using a ruler, but there is my line, and obviously because it's less or equal to, the region that I want is going to be below that line. So it's this region here, and obviously the key thing you also need to remember is that it's also need to mark this area here on the set of axes. So that's that one done. So moving on to the next one, so I've got x is greater than -2. So again, I'm going to replace the inequality symbol with an equal sign. Now x equals -2 is a vertical line, and if I just mark two coordinates like so, And because it's not equal to, because it's greater than, I need to connect those 2 points with a dashed line. And again, you try and use a ruler. However, again, not saying a very good example, but there we go. And because we're going for greater than, it's the area on the right that I want. So it's this area here and this area here. And don't be put off by the axes as a partition between your shaded area. Make sure that you are shading all the regions, because obviously if you just highlight this little area here, then obviously you're going to lose some marks. Now in question 3, I've got 2 that I need to plot. So again, looking at the first one, and again we'll try and keep the colours consistent. So here I want to plot x equals 4. So again, that is going to be a vertical line going through 4. And again, I want a solid line because it's and equal that number. So again, I'm going to try and join that up, and I'm going to do the shading at the end. Now y equals 0 is a horizontal line going through 0, so it's going to be this line here. Now looking at the first equation of x is greater or equal to 4, then I want the area that's on the right of that line, so it's this region here that I want for that. And looking at the y is less than 0, well, that's going to be below, so that's going to be this region here. Now if a question asked you for an equality that satisfied both situations, then I'm looking for the area that is shaded in by both of those 2 colours. So if our question did involve working with both, then what I would do, it would be this region here, and I'm marking in green, which is satisfies both. So satisfies both inequalities. Now looking at diagonal equations, so here what I want to do is, again, I'm going to replace the inequality. So the question is asking me to plot or represent the inequality of y is less than 2x plus 1. So again, what I want to do is I want to replace the inequality with an equal sign, and this is the equation that I now need to plot. Now from this, we now need to do a table of values. Now to draw a straight line, you only need technically 2 points, but I'm going to go for 3 just to make sure. And again, if you remember watching from the video, I'm just going to pick 3 small numbers for x, and I'm going to substitute it into this equation to work out what the y ordinates are going to be. So for this coordinate here, I'm going to swap x for 0. So it's going to be 2 times 0 plus 1, which is 1. For this coordinate here, I'm going to swap x for 1. So it's going to be 2 times 1 plus 1, which is 3. And for this coordinate here, it's going to be 2 times 2 plus 1, which is 5. So these are the coordinates that I'm now going to plot. So I'm going to plot 0, 1, which is here. I've got 1, 3, which is here. And I've got 2, 5, which is going to be here. Now from this, what I then need to do is decide, am I going to connect those points with a dashed line or a solid line? Now because obviously I've got no equal sign, it's going to be a dashed line. So for this, what I need to do, and again this can be really difficult because I haven't got a ruler, so what I would do is I'd connect these points up, and maybe I would have a few more points just to guide me. But you need to make sure that when you are doing this, that you are kind of making sure you are crossing all the axes and extending that line as much as you can. And we go from there. Now, because we've got less than, we want the area that's below the diagonal line. So the area that's below the diagonal line is going to be this region here, which I'm going to use my highlighter. So it's going to be this here. Because although it doesn't look like below the line, it is going to be there. Now again, when it talks about a checkpoint, so for example, to check your answer, if I just pick a point, so let's go for a nice easy point, let's go for 2, 1. I'm going to use 2, 1 as a coordinate. Now this is my x value and this is my y value. Now if I substitute the values into this equation where I've got y is less than 2x plus 1, well if I substitute x equals 2, I'm going to end up with 4 plus 1, which is less than 1, and then I've got 5, and I simplify that. Now then all I've got to decide is this statement true? So is the inequality pointing at the smaller number, or is the crocodile eating the bigger number? So that is true. So that means then I've highlighted the correct area. Now, in some cases, a question might ask you to do this method of checking your answer, but again, sometimes it's one of those things that if you've got, like, say, a spare couple of minutes and your teacher says, have you checked your answers, which if you're just sitting there doing nothing in an exam, then this is one thing you could do to check your answer. So let's have a look at another example. So here, again, what I want to do is I want to replace the inequality with an equal sign. So this is the equation I now want to plot. So again, drawing my table of values. Again, I'm going to pick three nice small numbers. So I'm going to go for 0, 1 and 2. And then all I need to do is to swap the x ordinate into the equation. So I've got 4 take away 0, which is 4. This one's going to be 4 take away 1, which is 3. And this one here is going to be 4 take away 2, which is 2. So then all I need to do is plot those coordinates. So I've got 4, 0, which is here. I've got 1. Oh, I plotted that wrong. So let's just, again, typical mistake that most people make. So 0, 4 is here. I've got 1, 3. And I've got 2, 2. Now all I need to do is now join those points up. And again, just need to decide, am I using a solid line or a dashed line? Now, because obviously it can equal, it's going to be a solid line. So for this, I am actually going to try and do this correctly and hopefully not use a highlighter. Get rid of that, and let's use a colour. And so I'm just going to first go through those points and extend it. We're seeing why I probably opt for drawing this freehand. And there is my final answer. So there we got. Now all I need to decide is, do I want above the diagonal line or below the diagonal line? Now because this is greater, I want above the diagonal line. So this is the region that I want. And there we go. Now again, if I want to have a checkpoint, so for example, if I have a checkpoint, something nice and easy, let's go for 3, 3. So I'm going to check with the coordinate of 3, 3. So again, swapping the numbers, I've got 3 and I've got is less than 4 minus 3. So again, all I've done is I've swapped my y ordinate and my x ordinate with the 2 inside the original equation. So I've got 3 is less than 1. Now, is this true? Yes, it's true. So therefore, I've shaded the correct section. So let's just do one last one. So this one here, we haven't actually got a value, an equation that's got y the subject. So what I'm going to do is, to make my life a little bit easier, I'm going to take the x over to the other side. So what I've got is I've got y is less than 1 minus x. Now from this, what I'm then going to do is replace the inequality sign with an equal sign. And again, from this, all I need to do is simply swap the ordinates in. So here I'm going to have 1 take away 0, which is 1, 1 take away 1, which is 0, and 1 take away 2, which is minus 1. So then plotting these coordinates, I've got 0, 1, which is here, 1, 0, and I've got 2 minus 1, which is there. Then all I've got to do is decide is, am I going to use a dashed line or a solid line? And it's going to be a dashed line because there's no equal sign. So again, I'll have to do this freehand. Let's just get a different colour pen. And as accurately as I can, join those points up. And there we go. And looking at the sign of the inequality, it's less than, so I want below the diagonal line. So it's going to be this region here that I want. Now, sometimes the question might ask you to shade, sometimes it might ask you just to label it R, and that's going to be absolutely fine. It doesn't really matter where you label the R, as long as it's in the right section, on the right side of the boundary line, then that is going to be absolutely fine. Now, as mentioned previously, in more higher level questions or higher mark questions, you may have to involve a combination of certain inequality graphs and lines. So in this question, it says, on the grid, clearly indicate the region that satisfies all of these inequalities. So what we're going to do is we're going to join these types of questions together. Now, I strongly recommend that you do each inequality one at a time. And when it comes to shading, you leave that right till the end. So for example, with this first one, what I need to do is I need to plot x equals 3. Now, x equals 3 is a vertical line through the number 3, And I then just need to decide, is it going to be a solid line or a dashed line? And in this case, it's going to be a solid line. So all I'm going to do is draw a solid line through x equals 3. And again, I should be using a ruler. For the next equation, I'm going to draw y equals 1. And so y equals 1 is a horizontal line through 1. And again, I just need to decide, is it a dashed line or a solid line? In this case, it is a solid line. And then finally, for the last one, I need to plot x plus y equals 5. Now, one thing with regards to these types of equations, you could make y the subject. So I could then go on to plot 5 minus x. Alternately, what I could do is try and find two values that add up to 5. So for example, if I've got x plus y equals 5, so all I've got to do is, using the numbers on the y and the x scale, I just need to find two numbers that add together to equal 5. So for example, if x equals 2, then y must equal 3. So one coordinate is going to be 2, 3. If I should be using a different colour, so let's go for green. So one coordinate is going to be 2, 3. Another coordinate could be, well, if x is 4, then 4 plus 1 equals 5. So my next coordinate is going to be 4, 1. So plotting these coordinates, I've got 2, 3, which is here, and I've got 4, 1, which is here. Now again, I'm going to connect those points with a line, and it's going to be a solid line because it's x plus y is less or equal to y. So again, drawing a solid line through those 2 points, and again, should be using a ruler. I get that. Now the next thing I've now got to do is highlight the region. Now the region that I want is got to be, well, taking each equation at a time. So for the blue, it's going to be to the left, so it's going to be this region here. For the green, for the y, it's going to be above the line, so it's going to be this region here. And for the diagonal line, it's going to be underneath the graph of the line, so it's going to be this region here. Now, although my graph looks incredibly messy, the region that I want is the region that is shaded by all of them. Now, if I just get rid of the shading that's only shaded by one or two of the colours, then what I'm going to be left with is, now again, I'm just going to delete all the shading, not ideally what I wanted. But basically, the region that's going to be shaded by all three was actually this little triangle here. And that there would be my region. And what I'm just going to label that R, or I could shade it in. But that would be the region that satisfies all three of those inequalities. So let's have a look at another question. So here we've got three different inequalities. Now here we've also got a combination one. So here we've got that x is between -1 and 2. Now for this, first of all we need to establish it's going to be a vertical line between those three numbers. So what I need to plot here is I need to plot, and try and find the right colour. So for -1, can't see that. So we go for -1, x and 2. So I need to plot -1 equals x. I need to plot x equals 2. So x equals -1 is going to be this line here. Now I'm going to use a dashed line because there's no equal sign there. So I'm just going to dash a line through -1, and I'm also going to dash a line through +2, which is this region here. Again, should be choosing a different colour, so let's just make that a little bit easier to see. So let's go for -1 x equals 2. Let me just dash that line through -1. And again, what you should be doing is using a ruler. Again, with me doing this on the computer, it's going to be a little bit difficult. Now for the next one, let's go for green. So again, I'm going to plot y equals 8. Now y equals 8 is a horizontal line, and again I'm going to draw a solid line for this. So that's going to be there. So that's y equals 8. Now again, very good practice is for you to label your lines. So that's equals -1, and that's x equals 2. And then for the last one, I've got y is greater or equal to 4x minus 4. So again, I'm going to do my table of values. So again, I'm just going to pick three small numbers and then substitute it in. So here I'm going to have 4 times 0, take away 4 is -4. 4 times 1, I don't know why I've put 4 times 4, it's confused me there. Let's just get rid of that. So we've got 4 times 1 take away 4, which is 0, and then 4 times 2, take away 4, which is positive 4. So plotting these coordinates, I've got 0 minus 4, which is here. I've got 1 4, which is there, and 2 4, which is here. And I've plotted that one wrong, so let me just correct that and plot that there. Now I'm going to join those points up with a solid line. So again, trying to be as accurate as possible in terms of the line that I'm drawing. Now here it comes to the shading. Now you can pretty much guess the area that's going to be. It's going to be this middle section here. But let's just double check to make sure that we are using the correct area. So for this I'm going to use my highlighter. So for the area that's trapped between the two x values, that the value needs to be within that region here. Now for y is less than 8, that's going to be below the green line. So that's going to be this region here. And if I choose a different color highlighter, let's go for blue. So here I'm looking for where it's above the diagonal line. So above the diagonal line is going to be this region here. Now what I'm looking for is a region that's shaded twice, and the area that's going to be shaded twice is this area here, which I'm just highlighting in purple. Again, just to emphasize that, let me just get rid of all this shading just to make it a little bit easier. Just working on a slight delay, not at all annoying. And just get that. So the region that I want, I'm just going to highlight in pink, is going to be this region here. And that's the area that satisfies all three of those inequalities. And in terms of the shading, if I shaded it individually, it would be the area that's shaded by all three lines. So it's been shaded 3 times. So that would be my region there. So moving on to this similar question. So here what we're going to do is we're first going to plot x equals 2. So x equals 2 is a vertical line. So we just got to decide, is it going to be a dashed line or is it going to be a solid line? In this case, it's going to be a solid line. So I'm going to draw a solid line from there, and I'm just going to label this as x equals 2. Now looking at the inequality, I want this side of the line that I've just drawn. Now moving on to the next one, which is the diagonal line, which I'm just going to do in green. So here we've got to plot y equals 2x minus 2, and we've got to do my table of values. So again, I'm going to go for 0, 1, 2. So substituting this, I get minus 2. I'm going to get 2 times 1, which is 2, take away 2, which is 0. 2 times 2, which is 4, take away 2 is 2. So plotting these points, I've got 0, minus 2, which is there, 1, 0, which is there, and 2, 2, which is there. And I'm going to join those points up with a dashed line this time. So just start off with those 2 points there, and then just continue the line and go from there. Now from this line I want the left or above the line, so it's going to be this region here. It's going to be that region there. I'm going to highlight, and then finally the last one I've got to do, which is x plus y plus 2 is less than 0. So if again here, what I need to do is, now I probably would recommend that you take the 2 and take the 2 and the x over, so we get y is equal to minus 2 minus x, and then we can then work with our table of values to then substitute this in. So again here I've got x, I've got 0, 1, 2. Let's just do a little table, and so here I've got minus 2 minus 0, which is minus 2. Here I've got minus 2 minus 1, which is minus 3, and here I've got minus 2 minus 2, which is minus 4. So plotting those coordinates, I've got 0 minus 2, which is again a plot point I've already plotted, and I've got 1 minus 3, which is here, and 2 minus 4, which is here. And again I'm going to join that line. Now I want the line that's to the right of that line, so again just joining those points up, and again like so. And so the region I want is above that line, so it's going to be this region here. And like I said, with a bit of practice and with a bit of sort of common knowledge, you'll see that it's going to be the point that's enclosed by all three boundaries. So the bit that satisfies both is going to be this region here. So that's what I'm either going to shade, or I could label that as R and circle around it. And there we go. Now, in more high-level questions, you might be asked to work backwards. In this case, that's when you're given a diagram and a region in a shaded area, and you need to write down the inequalities that satisfy that shaded area. Now, in this particular question, our area is not shaded. It's represented by the letter R, but all I'm going to do is just colour in that little region there, so it just emphasises it a bit more as I explain it. Now, in terms of this, what we need to do is we need to write down the equations of each of these lines. Now, again, this is covered in a previous video for you to write down the equation of a straight line. Again, I'll include a link to that video if you're not too sure on how to do that, either now as it pops up or at the end of the video or in the description below. Actually, I'll do all three, so it'll be fine. So looking at the equations in synchrony, so let's do the simple one. So let's do for this one here, we'll label this one number 2 and this one number 3. Now looking at equation 1, that is a horizontal line, so that's going to be y equals 2 because it goes through 2. The vertical line is going through 6, so that's going to be x equals 6. And the diagonal line, if I notice the coordinates, well, here I've got the coordinates of 0, 0, 2, 2, and then 4, 4. So that's going to be the equation of y equals x. Now, from this, what I'm now going to do is I'm just going to write the equations, but I'm going to exclude the equal sign. So the first one, I've got y equals 2. And let's rub that equal sign out. And then for the second one, which I've done in green, so let's going to do x and 6. And for the third one, I've got y and x. Now, in terms of the regions that I want, well, R is on the, if looking at the first equation of y equals 2, now I want the region that's above. So the region R is above that line, so that means it needs to be like that. And because it's a dashed line, I don't want to put a line underneath the inequality, so that's going to be that there. Now looking at x equals 6, the region R is to the left of that sign, so then therefore, and also that's going to be a solid line, so I need to put a line underneath it. And likewise for y equals x, the region R is below that line, so that means then it's going to be less than, and it's a solid line, so I'm going to put a line underneath it, and that there is my final answer. Now with these types of questions, you might get asked to have a checkpoint, so I'm going to have a checkpoint of, let's go for 5, 4, so I'm going to go for this coordinate here, so my checkpoint is 5, 4. Now with this coordinate, x is equal to 5 and y is equal to 4. Now all I'm going to do is I'm going to substitute these two numbers into these three inequalities and see if it's actually true. So here I've got y is less than 2, so I'm going to swap y with 4. I've got x is less or equal to 6, but in this case I've got x equals 5, so I've got x and 6. And here I'm going to swap both x and y, so I've got 4 and I've got 5. Now all I'm going to do is I'm just going to go through these and check if it's true. So is 4 greater than 2? Yes. Is 5 less or equal to 6? Well, yes, it's less. And is 4 less or equal to 5? Yes. So that therefore means that this is correct. Now, if any of those were wrong, then one of my inequalities would be incorrect, and either I've got the sign the wrong way around or I've got the equation completely wrong. So let's have a look at another example here. So again, I'm going to start by labeling the 3 lines. So I've got 1, 2, and 3. And it's this region that I want, which again I'm just going to emphasize by shading it in. So looking at the equations of each of those lines, so this is a vertical line going through 4, so that's going to be x equals 4. So I'm going to do is have x and 4. The second line is a horizontal line, and that's going to go through 4, so that's going to be y equals 4. And in terms of this diagonal line, well, again, looking at the coordinates, so I've got 0, 2, I've got 1, 4, I've got 2, 6, and I've got 3, 8. Now, if you imagine this is like nth term in terms of sequences, so if I can just ignore the first one. So imagine this is like sequences, so the difference here is 2. So that means I'm definitely going to have a 2x in my equation. And then how do I get from 2 to 4? We'll need to add 2. So then the equation of the line is going to be y equals 2x plus 2. So what I'm going to do is write y, and I'm going to write 2x plus 2. Now the next thing I need to do is then decide on my inequality signs. So for this first one, the region R is on the left of that side, and it's a dashed line, so it's going to be less than, with no line underneath. For equation 2, which y equals 4, I want above the line, and that again is a solid line, so that's going to be greater than 4. And then finally, for the last diagonal line, the region R is below the diagonal line, so that's going to be facing that way, and it's got a solid line, so it's going to have a line underneath, and that there is my final answer. Now again, it's always good practice for you to check, so let me just create a bit of space and get rid of all of this. So what I'm going to do is I'm going to find a checkpoint and try and go for most nice numbers. So again, here I'm going to go for one that's definitely not on the boundary, so I'm going to go for 2, 5. So my checkpoint is 2, 5. So x is going to be equal to 2 and y is going to be equal to 5. I'm just going to write down these numbers. So again, wherever I see an x, I'm going to swap it for 2, and wherever I see a y, I'm going to swap it for 5. So here I've got 2 and 4. Here I'm going to have 5 and 4. And then here I'm going to have 5. And then I've got 2 times 2 plus 2. So now all I'm going to do is now just check to see if this is true. So is 2 less than 4? Well, yes. Is 5 greater or equal to 4? Yes. Now if I work this out, I get 6. And is 5 less or equal to 6? Yes. So therefore, this all looks great. Now that brings us to the end of this video. So what I'll do is I'll include some example questions, practice questions I should say, along with their answers for you to practice everything that's covered in this video. Now the next step, carry on from this, will be moving on to quadratic inequalities, which again there will be a link at the end of this video.